This allows the top satellite to use any planet under the exact same lighting conditions, which is extremely useful for imaging applications. Once operational, Hoth will be capable of generating about 100 images a day, covering an area of more than 300,000 kilometers square. And as we mentioned earlier, there are two SpaceX test satellites flying as secondary payloads on this mission. These are meant to gather data in advance of deploying and operating a satellite constellation that will provide internet service. However, even if these satellites work as planned, we still have considerable technical work ahead of us to design and deploy a low Earth orbit satellite constellation. This system, if successful, would provide people in low to moderate population densities around the world with affordable, high-speed internet access, including many that have never had internet access before. You may catch a glimpse of these demo sats when we deploy the Hoth satellite, but our coverage and focus today will be on our primary payload, which is the Hoth satellite. We are just after T-minus 3 minutes away from liftoff, so let's check in one last time with the status of this rocket. Fuel is fully loaded on both stages, and liquid oxygen is being topped off as we speak. Right now, the rocket is pressurizing itself with helium gas, sort of like a soda can that derives some of its strength from the pressure inside. The Falcon 9 is pressurized with gaseous helium, and we press that up just before releasing it from the strongback. You just saw those cradle arms from the strongback release, and right now the transporter record strongback is reclined to its launch position at 77.5 degrees. Right now, the range is still giving us a green light for launch. The weather is again looking fantastic. Those upper level winds are still playing nice at 95% launch tolerances. Remember, this is an instantaneous launch window, so if for any reason we decide not to go today, our backup window will be tomorrow at 6:17 a.m. Right now, the rocket's getting ready to launch, so let's listen into those countdown nets as we approach just under T-minus 2 minutes.
Falcon 9 is on internal power. Vehicles and subline. Gas loads are close down.
AFGS is spawned ready.
Falcon 9 is in startup.
LD, go for launch.
T-minus 30. 20. 15.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. Vehicle pitch damage. Stable propulsion's nominal.
those of you just joining us, you are watching the Falcon 9 as it descends through the atmosphere, carrying the hot satellite to a polar sun-synchronous orbit. Right now, the rocket is approaching what we call max Q. This is the point at which the aerodynamic forces in the rocket are at the greatest. Falcon 9 actually throttles itself down as it passes through max Q and then throttles back up once we're through it.
Vehicle has reached maximum aerodynamic pressure.
We just passed through our maximum aerodynamic pressure, max Q. That Falcon 9 rocket is now throttling back up full speed as it descends through the atmosphere. As that first stage ascends higher and higher through the atmosphere, the ambient air pressure starts going further and further down, so you can see those exhaust gases getting bigger and bigger on your camera screen right now. In about 20 seconds, we're going to be passing through what we call MECO, which is main engine cutoff. That's when that first stage is going to complete its burn. Shortly after that, we'll have stage separation, and then second engine start, SES1. Let's watch that happen now. MECO. You just saw it on your screen. That was a good MECO, main engine cutoff. A good separation of that first stage, and then what appears to be a successful second engine start one. Stand by for fairing deploy. And you just saw it on your screen. That was a successful fairing deploy. You can see the fairing falling down below the second stage on your screen right now. SpaceX will be attempting to recover this fairing today. On your screen right now, you can see the Merlin Vacuum D engine nozzle. This is a radiatively cooled engine nozzle, meaning that it vents the heat from those hot exhaust gases by radiating that energy. You can see it glowing red hot, burning that energy away. For those of you down in Southern California, you might get a good glimpse of those exhaust gases as the second stage accelerates. Looked like a nice clear morning today in Los Angeles. As the second stage ascends higher and higher into orbit, let's talk a little bit about exactly what orbit we're going to today. This is a low Earth orbit, polar sun-synchronous orbit. Low Earth orbit refers to the height of the orbit above the Earth, so things such as the International Space Station are also in low Earth orbit, but they orbit more along the equator, which is what's called a low inclination orbit. A polar orbit circles vertically above the Earth with respect to its poles, so that it passes over the north and the south poles. This is the orbit we're going to today. Certain types of polar orbits, like this one, a sun-synchronous orbit, keeps the orbit's plane directly in line with the sun. This allows any satellite that's in a sun-synchronous orbit to see all points of the Earth from exactly the same lighting conditions as illuminated by the sun. This is extremely useful for imaging applications, which would be the spacecraft's primary intended purpose. Low Earth orbits only require a single burn, so we won't be having a coast phase or a second engine start too, like we would normally have for geosynchronous Earth orbit launches.
Vehicle is safe.